Hey friends, welcome to the YouTube channel All About Electronics. In the previous introductory video, we understood what is ADC and DAC. And then we had listed the different types of ADC and DAC which are commonly used in electronics. So in this video, let us understand in detail about the binary weighted resistor type of DAC. But before we do that, let us briefly discuss about the DAC, as in the previous video we have mostly discussed about the ADC. So this DAC converts the digital input into the analog output. So here the digital bits are applied as an input, and at the output, according to the applied digital bits, we will get the analog output. And apart from this input and output, the reference voltage is also applied to this DAC. So in some DAC, this reference voltage is generated internally, while in some DAC, it is applied externally. So this reference voltage decides what is the maximum output voltage which is possible for the given DAC. Now here, for the particular digital code, we will get the fixed analog output. But if the digital code is changing continuously at the fixed interval, then the output will also change continuously. But actually if you see the output of the DAC, then it will look like this. And by passing the output through the filter, it is possible to smooth out the output. But here, actually the resolution of the DAC decides how closely the output of the DAC matches with the actual waveform. And by increasing the resolution, this step size can be reduced, and then the output of the DAC will be much closer to the actual waveform. Now, as I said in the previous video, the resolution of the ADC or DAC is defined in the number of bits. So for a 3-bit DAC with a 5 volt of reference voltage, the resolution can be defined as V reference divided by 2 to the power n. Now many times this reference voltage is multiplied by the internal gain of the DAC. So there is always a multiplying factor with this reference voltage, and it depends on the construction of the DAC. That means how the DAC is actually designed. And sometimes the manufacturers also provides the provision to the user to select the internal gain from the specified values. But here let us assume that the value of K is equal to 1. So the reference voltage can be given as 5 volt divided by 2 to the power 3, that is equal to 0.625 volt. So here is the